All right, welcome everyone to day 12 of my journey of becoming a software developer. I'm going to solve a problem that it's out of the list of the problems we've been exploring for the past couple days. So remember how we've been going through the problems in Neat Code 150, specifically in the roadmap, and we're trying to go through like arrays and hashing, and we've been solving these problems for the past couple days. For today, the problem was valid Sudoku. What happened is that valid Sudoku requires you, based on the study material we've been following, to know certain things. So a valid Sudoku is just a matrix problem, right? Where and you can see here I have all my tabs open, just basically trying to understand and investigate a little bit the things I have to know for solve these kind of problems, right? So it's a matrix problem. We're going to need some previous knowledge. So I just decided to deep down a little bit and check other problems that we need to practice before we get to problems like valid Sudoku, right? Trying to put a logic behind the learning process. So follow me today and let's go ahead and solve the problem. So the first thing we need to do in order to solve a valid Sudoku problem or type of problem is to understand a few things. And a couple of those things are a matrix traversal pattern. So what is a matrix traversal pattern and how do we traverse a matrix? Well, I'm going to just put it in a note over here. This is a matrix right here. And basically, this is an easy problem, and this is where we have to start in order to get to the point where we're going to work with other data structures, right? You can see the companies that, based on LeetCode's information, ask this type of questions. But the matrix I have right here, basically, there are certain problems where we're going to need to validate certain things that are happening in the matrix, right? So if we look at the Sudoku problem, and I'm going to go ahead and pull it up from here, just bear with me. The valid Sudoku, I'm just going to check it out from NeetCode. We probably all have played Sudoku before, or however you call it, you know. I'm probably having a little Spanish accent there, but just go ahead with me. This is a Sudoku grid, right? Where we have to fill the numbers in every row and every column for each specific square here or grid, right? It's a 3 by 3 grid in every case. And no numbers are allowed to be repeated. That's like the basic rule of Sudoku, right? So, but also based on the grids, you have a 3 by 3 board that it's also 3 columns, right? And 3 rows. And the whole structure is it's a 9 by 9 board, right? Because it has nine um, 9 total of rows and 9 total of columns. If we look at it as the whole grid, right? And the to get to the point where we solve this kind of problems, I investigate and we need a few things. We need to know how to traverse a matrix. This is a matrix, and this is how it's represented using an array data structure. So we need to know how to, and we can see here in Python terms, this is a list of lists, where the outside list, it's going to represent the number of rows we have, and the inside lists are going to represent the number of columns. And there are simpler examples to do that, but the best problem to get there is this: transpose a matrix or matrix, right? So the thing with the matrix, and we can see here, right? We set a list of lists. We have an outside list, we have an inside list. So the outside list represents the rows that we have here. So we have 2, minus 10, and 18, 4, 5, minus 7, minus 1, 11, and 6. And Those are the columns, actually. I call them rows. I made a mistake. These are columns, right? Obviously. So I just read the columns. The rows are 2, 4, -1, -10, 5, and 11, 18, -7, and 6, right? These are our rows. So what happened is that we have to rotate these numbers, right? And it says here, flip over in its main diagonal, right? And as we can see here, so every row, it's basically going to be flipped to its main diagonal, right? So the flip we're seeing here is we see how this row up here just became a whole column. We see how this row from here became the second column, and this row from here became the third column, right? So we don't need any magic to do this problem. All we need to know is that we're going to need an extra data structure, an extra array, right, which is going to be the resulting array, where we're going to grab all the numbers from here and we're going to deposit them in the transposed matrix, right? So that's like the whole concept with this. It's pretty intuitive to start with problems like this before we jump into bigger problems like the one we were talking about with the Sudoku, because we're going to need to do some hash computations. That's another topic we have to know before we get here. But also we're going to need to transpose this matrix to find certain values to make the board valid, right? So first of all, we're going to start with the problem of transport matrix or matrix. We're going to start transposing the matrix, and we see here that we have an input array, or an input array of a list of lists that it's going to be our matrix, and we're going to output another matrix, right? So what is the first step we need to do? Well, the first thing we're going to do is separate rows and columns, right? And how do we do that? Well, we have to get a hold of the rows and columns in our matrix. So we say, since we know it's a list of lists, the rows are going to be everything that is inside of the outside list. So everything that's inside of the outside list. And the way to get a hold of that is saying, rows is going to be equal to the length of the matrix, the length of the whole matrix. Why? Well, because we want to get a hold of everything that's inside, and everything that's inside, it's the total number of elements inside of our matrix. And I hope that makes sense, right? The second thing we need to do is to get a hold of the columns. What happened with the columns is that since we know a matrix is equal number, at least the matrix we're working on right now, it's equal number of rows and equal number of columns, right? It's a grid, a 3x3. In order for us to get a hold of whatever is inside, we just need to say we're going to go ahead and grab the matrix at index 0. And that's going to be our columns. Well, we're standing right here, but that is since we know everything else past that has the same number. All we need to do is grab the first 3 columns, and then from there we're gonna create our result matrix, our transposed matrix, if you will. So result, and this is going to be the way to do this in Python is, well, we need to have the same size matrix, right? As we see here, this is exactly the same as the other one. So every bucket, every space that we have in our rows and columns is going to be filled with this number. So it's got to be equal. Well, the way to do that in Python is we're going to initialize it with zeros, because we don't want any other number there for right now, because we want everything to be equal until we apply the operations in it. Then we multiply that by the number of rows that we have in our matrix, and then also, um, and you guys can see I'm using a list comprehension here to create that because it's going to be a list of lists, and a good way to do that in Python is a list comprehension. So we multiply that by the rows, and then we say for. We don't need to use we don't need to use any parameter here, so we're just going to do an underscore. That's a very Python thing to do, I believe. So, we're going to say, create a list times rows for, certain item in, and then the following thing we're going to use is the range function to iterate over the columns. So we're saying create an array, okay, inside of the range of columns. Columns, remember that we have here, is equal to our grid, which is equal to 3. So in our case right here, we have a 3 by 3. So this is going to be equal to 3, and this is also going to be equal to 3. And I'm just going to put that over here. Rows equal 3, columns equal 3. And that's just a little example here. But yeah, here we have our grid, and this is how we have our grid, our new resulting grid created, right? So what do we do now? Well, it's easy if we think about it, because all we need to do is grab every element from our matrix that we have separated and pass it into our new matrix, right? So how do we do that? So we're going to say for every item in the range of, first we're going to grab the rows, right? We're going to iterate over every item in rows, and then we're going to say for every other item, in this case J, to use a different element here in the range of, well, now we have the rows and now we need the columns, right? So what do? Well, we got a hole here of every individual index in the outside. So the first iteration is gonna do a pass through here, then it's gonna grab the second one, then it's gonna grab the third one, right? And the second one in columns is gonna go ahead, and it's working inside. It's gonna grab every number in here, right? So what do? Well, we say go ahead and make our resulting matrix or grid at position I, which is what are we iterating through? We're gonna fill every box, right, in rows. So every box in this rows right here, we're gonna fill it up. And also every box in our columns, right? So we're going to go rows by rows, columns by columns. So we're saying, append or grab every item in this box, and in this box is in rows and columns, and make that whatever we have in our matrix at, since we're trying to traverse, we have to what? We have to change the elements. So we're saying basically this element stays the same, so it doesn't change. But this element right here, when we're iterating through this element right here, what's going to happen is that I'm going to go and since I'm flipping things diagonally, this element's going to go right here. And this element right here is going to go, this element right here is going to go right here. So it's going to be one pass through every element. So we can see something that it's interesting, because diagonally 2, 5, and 6 don't change their position because everything is going around them, right? Everything's changing diagonally. So the way to represent that here is changing everything in our rows and columns and making it equal everything in our columns and rows, right? Remember, this is rows, this is columns, and this is columns, and this is rows. It's basically flipping everything, and then I think we're done, because all we gotta do is just return, all we need to do is return, if I can write that right, our resulting array, because, or matrix, because everything has been flipped. And I believe that's going to be it for our solution. Okay, I see I have an error here. Result at, what does it say? Index out of range. So I'm saying result. Oh, okay. I'm saying I and J and so this actually I see something I did wrong here. We want to grab every column and row from here and make it every column and row, and making every row and column instead. I was iterating backwards. So this is going to work better. And there it is. That's how we traverse the thing. The matrix. I got a little excited there. But anyways, we see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and the 1, the 5, and the 9 in both cases, as we can see here, these are different numbers, but these are diagonally. If we stack this on top of each other, and I'm just going to do it right here real quick as an example. I'm going to try to stack them on top of each other so we see how this thing works. It's pretty cool because that's exactly what we are creating. I think visually it's represented better like this, right? So this is the first one, and the second one is this one. Let's see if I could do it a little faster since I already and all I'm gonna do is send this one down. And then I'm going just to paste this one from here to here. I'm going to need the whole thing. Okay. And I gotta separate them so we know where we at. Okay, so this is the first one and this is the second one. I'm going to take the outside brackets just so it like kind of fits neatly. Let's do this. I hope we can appreciate. So we see here 1, 5, and 9 going diagonally, and we see here 1, 5, and 9. However, this one down here, it's our output. And what we're doing is we're sending everything in this column to everything in this row to this column. So we can see here 1, 2, and 3 are stacked in a row, but we're sending it to the column right here. And this is what we're doing here. We're grabbing the rows, we're grabbing the columns from here, so these ones, and these columns are becoming whatever is in this. These columns are becoming whatever are in these rows. So what are in these rows? 1, 2, and 3. What are in these columns? 1, 2, and 3. What are in these rows right here? Whatever are in these columns over here. So in the rows of in the rows of result, which is this array right here, what do we have? So we have 4, 5, and 6 in this case. What do we have here? 4, 5, and 6. So as we can see, it's very, I would say, pragmatic the way to do this. It's an easy problem, but it's gonna help us to get to harder problems. And yeah, that was pretty much for today. I hope you enjoy the video. As you can see, it's learning life. I'm gonna make a couple of mistakes, but that's okay. That's the whole process of getting better. If you don't do that, if you don't try to get better than what you're doing, you're gonna make mistakes, especially if you're recording or if you're putting something for someone out there. So let's just be honest with ourselves, and that's the whole point of this. I'll take criticism anytime. So yeah, let's go ahead and do it. I hope you liked the video. Please subscribe if you got something from of value from here. If you really wanna just follow me in this journey, like the video and subscribe. It really supports me a lot. See you later.